Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts from science and maths. Now, since past few episodes we have been talking about spectroscopy, and the last episode was about vibrational spectroscopy. So you got introduced to vibrational spectroscopy. Now we need to continue it further. So if you recall, in the previous episode we have discussed what electromagnetic radiations are, and what spectroscopy is, and how a spectrum looks, and so on and so forth. And we deliberately discussed the concept of wave number in detail, because in the spectrum of infrared spectroscopy, which is basically part of vibrational spectroscopy, you will see that on the x-axis you have wave number. So we talked about the concept and the unit, etc. We also discussed how different regions of the electromagnetic spectrum are divided, and the cause of the energy changes that arise there, and which kind of spectroscopies are relevant for which region. So if you want to revise all these concepts, then you can visit the previous episodes. Now let us move forward. So we have mentioned that for vibrational spectroscopy, our concerned region is the infrared region, and that here the energy changes involve transitions between the vibrational levels of molecules. So what part of the electromagnetic spectrum is the infrared region? Now, if you talk in terms of wavelength, then you would say that infrared radiation covers the electromagnetic radiation between around 1 to 1000 micrometer. Now please understand that 1 micrometer is 10 raised to minus 6 meter. So if you are talking in terms of frequencies, this would be 10 raised to 11 to 10 raised to 14 hertz. And then if you are talking in terms of a wave number, it will be 10,000 to 10 centimeter inverse. Now, this particular infrared radiation is also then subdivided into certain sub-regions. And what are these regions? These three regions are called near infrared, infrared and far infrared regions. So in terms of wave numbers, 10,000 to 4,000 centimeter inverse is for near infrared. Then 4,000 to 200 centimeter inverse is for infrared, and 200 to 10 centimeter inverse is for far infrared. So obviously you see that the wave number corresponding to near infrared is larger as compared to the wave number corresponding to the far infrared, which means the wavelength corresponding to near infrared is smaller than the wavelength corresponding to far infrared. Now, as you are aware, infrared region is sandwiched between microwave region and visible region. In fact, the wavelength range for near infrared is from 700 nanometer to 1300 nanometer. Or if I have to talk about it in micrometers, that is microns, it is 0.7 micron to 1.3 micron. And if you compare it with far infrared wavelength ranges from 15 micrometer to 1 millimeter. So you should, if you want to remember it, the terminology near infrared is near to visible light, right? Because what is the wavelength regime for visible light? 400 to 700 nanometer. So beyond 700 nanometer up to 1300 nanometer, the region is near infrared. So you can remember it that way. And due to these specifications of wavelength and frequency, you have different uses. Like for example, near infrared is mainly used for night vision imaging or remote sensing, atmospheric detection, optical communication, etc. While far infrared is used for detecting, say, protostars, or studying some central regions of galaxies and so on. Now, please understand that in terms of their interaction with human body, near infrared region of mid infrared region and far infrared region is going to have different penetration power. So now infrared radiation is not visible in the terms, I mean, not just, I don't mean to say it just in terms of visible radiation, but we can't see it. That is what I mean. So, how do we sense it? We sense it like heat. So, if you put your hand near a hot object, the heat that you sense, it's the infrared region. It's coming from the infrared region. Now, sometimes some people also tend to say that there are five subregions in infrared, and they call it near wavelength, short wavelength, mid wavelength, long wavelength, far infrared, etc. But even if you remember, there are three main regions, that's all sub-regions, that's also sufficient. If you talk about the history, then infrared light was discovered by William Herschel in long back in 1800, and he was a British astronomer, and he was doing an experiment to measure the temperature difference between the colors in the visible spectrum. So while doing that, he placed thermometers in the light path within each visible spectrum color. And he noticed that there was an increase in the temperature when you move from the blue region to the red region. And then he found that beyond the red, there was even warmer temperature measurement. So it was called infrared. And since we mentioned it's associated with heat, obviously much of the energy received from the sun is going to reach the earth in the form of infrared radiation, because we know, right, sun gives us both visible light as well as heat. It is also related to several aspects in the environment, because materials like ozone, carbon dioxide, water vapor, they absorb infrared radiation. So I'm sure you must have heard about greenhouse effect arising from such consequences. Now, apart from the applications that we mentioned, whether it was communication or whether there are some medical applications, but our prime interest, of course, right now is to see its application for, so infrared vibrational spectroscopy is used for identifying molecules. And how is it done? It is done by analyzing the bonds as the molecule vibrates at different frequencies. So there's something called as functional groups. We'll be discussing it later in another episode. So with especially with organic molecules, there are functional groups. For example, when you say ROH, you are talking about alcohols, right? So in this way, different organic compounds will have functional groups associated with them. And it's like a signature for every organic molecule. So if you want to identify that molecule, you need to check whether particular functional groups are present. And that information you are able to obtain from infrared vibrational spectroscopy. So we'll talk about other aspects in further episodes. Thank you.